All right, let's jump right in. We are all building these incredibly cool, sophisticated AI agents, but there's this huge challenge simmering just under the surface. How do we actually make them better? I'm not talking about just clever prompts. I mean fundamentally improving the models that are the brains of the operation. Well, today, we're going to look at a framework from Microsoft Research called Agent Lightning that tackles this exact problem head-on.
So you've done it. You've used your favorite tools, LangChain, AutoGen, you name it, and you've built this powerful agent that can do some really complex stuff. And it works, kinda, but it's not perfect. It still makes mistakes, it gets stuck, and you just know it could be better. You've basically hit a performance ceiling. Sound familiar? Yeah, it's a story pretty much every AI developer knows.
And the reason we hit this wall is kind of fascinating. It's because the whole world of AI agent development is basically split in two. You've got these incredible tools for building and piecing agents together on one side, and on the other, you have these super powerful methods for actually training the models. The problem? These two worlds barely speak to each other.
And this right here is the great divide. So on one side, you have your amazing agent development frameworks. LangChain, AutoGen, they make it a breeze to orchestrate these complex workflows. But they were never really built to handle the intense data pipelines you need for training. Then, on the other side, you've got your heavy-duty model training frameworks, especially stuff like reinforcement learning, which are amazing for optimization. But just try plugging your complex, multi-step agent into one of them. It's an architectural nightmare. They're just not built for each other.
This is the big question, isn't it? How do we connect the easy, fast world of building an agent with the powerful, effective world of optimizing a model without having to just throw everything out and start from scratch?
Well, you probably guessed it. The answer we're looking at today is Agent Lightning. It was designed from the ground up to be the bridge that finally connects these two separate worlds.
And this visual really gets to the heart of it. You've got your custom agent doing its thing on the left. It sends what are called training trajectories, which is really just a fancy way of saying a journal of its actions and what happened, through Agent Lightning over to a reinforcement learning engine. That engine then fine-tunes the model, makes it smarter, and sends the updated version right back. It's this beautiful, continuous learning loop.
And this is the promise that gets developers really excited. It doesn't matter if your agent is built in LangChain, AutoGen, or even just some custom Python script you wrote. Agent Lightning is designed to work with any of them. It's totally framework agnostic.
I mean, you gotta love this quote from the source material. It just says it all, right? The goal here is to make this whole process almost frictionless. The idea is you can take the agent you already have and, with practically zero changes to your agent's actual logic, plug it into this super powerful optimization engine.
So let's just quickly run through the core features that make this all happen. First, that seamless integration we just talked about. Second, and this is so important, is full decoupling. Your agent's code and the training code live in completely separate universes, as they should. Third, selective optimization. Got a few agents working together? Cool. You can choose to train just one of them or all of them. And finally, it's built for the good stuff, starting with reinforcement learning, but with plans for even more.
Okay, so how does it actually do this without making you rewrite your entire agent? The architecture is honestly pretty brilliant. They use what they call a sidecar approach.
And this diagram just lays it all out. It's called Training-Agent Disaggregation. Fancy name, simple idea. On the left, you've got the heavy-duty reinforcement learning stuff, chugging away on some big GPU servers. On the right, that's your agent, just running wherever it normally runs. The two are completely separate systems that just talk to each other through a server and a client. This is that decoupling we were talking about, in action.
Let's break that down even simpler. You've got two parts. The Lightning server is like the training gym. It's where the model goes to get stronger. The Lightning client? That's the non-intrusive sidecar. It's a tiny, lightweight piece of software that just runs alongside your agent, watching what it does, taking notes, and sending those notes back to the gym to learn from. No code changes needed in your agent.
So, the whole learning loop looks something like this. First, your agent just does its thing, maybe tries to answer a question. All the while, the client is silently in the background collecting a record of everything it did. Second, the client sends this record back to the server, but with a little note attached that says whether the final outcome was good or bad. Third, the server takes all this data and feeds it into the RL algorithm, which updates the model. And fourth, the server makes this newly improved model ready for the agent's next task. It's just a clean, constant cycle of getting better and better.
Okay, theory is great, but does it actually work?
Well, the researchers put Agent Lightning through its paces on some pretty complex real-world tasks. Let's see how it did. And they didn't just pick one easy task. They tested 3 very different scenarios to really prove this thing is flexible. First, a text-to-SQL agent built with LangChain. Then, a retrieval augmented generation or RAG agent that has to dig through Wikipedia built with the OpenAI SDK. And finally, a math-solving agent that needs to use a calculator tool built with AutoGen. This variety is what really shows off the power of the framework. So, let's look at the results. For the SQL task, these charts tell you everything you need to know. That line going up and to the right, that's exactly what you want to see. It means the agent got progressively better at writing and fixing SQL queries. And the best part? It improved on brand new problems that it never seen before, not just the ones it trained on.
Next up, the RAG agent. Now this was a seriously tough test, answering complex questions using all of Wikipedia as its brain. And what do you see? The exact same thing. A clear, steady improvement. The agent was actually learning how to ask itself better questions to find the right information and build better answers.
And finally, the math agent. This one is all about learning how to use a tool correctly. The agent had to figure out when to call its calculator to solve a problem. And again, the results show it got much better at it over time, which led directly to getting more answers right. This is huge. This tool use is a cornerstone of how modern agents work.
So, what does this all mean for the big picture, for the future of AI agents? Well, it signals a really fundamental shift in how we're going to think about building them from now on.
The main takeaway is this: we're officially leaving the era of static agents. Agents that are only as good as their initial training and their prompts. We are now walking into an era of dynamic, adaptive agents that can actually learn and get better from their own experiences out in the wild.
For anyone out there building agents, this is a real game changer. It means you can finally move beyond just fiddling with prompts and start truly fine-tuning the core behavior of your agent's model. It means you can train agents on your own private data without ever having to expose it. It means you can build systems that don't just do a task, but get better at it over time, all on their own. It finally bridges that gap between building fast and optimizing for real power.
And all of this really leaves us with one last fascinating question. For years, the dream has been to create agents that can learn and adapt, kind of like we do. With frameworks like Agent Lightning, that dream is quickly becoming a reality. So, if any agent built with any tool can now learn from its own successes and failures, what previously impossible problems are they going to solve for us next?